So we are going to go through the algebraic properties of equality, and I have these little posters. So I'm just going to use these to go through and highlight. So what you're going to want to do is jot down the name of the property, and then whatever it is that is helpful to you. So if you want to put the example, if you want to write the definition, whatever is helpful for you. To know and be able to recognize the different algebraic properties. And you might need to pause the video as you're going through them so that you can get the information that you need. All right, first one, reflexive property. So reflexive property is not one that we use very often in algebra. It's more used in geometry, but basically it says that a value is going to be its own value regardless of where it's located in the problem. So what that basically means for algebra is that if there's more than one x in the same equation, each x is going to have the same value. So that value for x is going to be consistent throughout the entire problem. So in geometry, we would say that, let's say, for example, that two rectangles shared a side. That side in one rectangle is going to be equal in length to the side in the other rectangle because that side is equal to itself. So that's what reflexive property is. And again, we don't really see it that much in algebra, except in that consistency throughout the one problem. Every time that variable is presented in the same equation, it has the same value. All right, the next one is symmetric property, and this one I use a lot. I like most of the time to have my variable when I'm solving an equation on the left side. So the symmetric property of equality is the one that allows you to reverse the sides of an equation or inequality. So the example at the bottom, AB equals CD, is the same as CD equals AB. So that's symmetric property. Keep in mind when you have an inequality, if you change the signs, sides, you have to change the inequality sign as well. The next one is transitive property. Transitive property is easy to identify because there's three parts to it. So if A equals B and B equals C, then A equals C. Another example of this might be if Tom is siblings with Chris and Chris is siblings with Mike, then Tom is siblings with Mike. So basically what happens is if two values are equal and then one of them is equal to another third value, then the first and third are going to be equal. So the example at the bottom is if x is 5 and y is 5, then x is y. So transitive property is easy to identify because there are three parts to it. If, and, then. Addition property of equality. So these next few properties are the ones that just allow us to go through the steps of an equation, which is why we're talking about this in this unit. So the addition property of equality is what happens when you add something to both sides. So in the very top, they added C to both sides. At the example at the bottom, to solve this equation, they add 10 to both sides. So it's addition property of equality. And again, that just means that what you add on one side, you're adding on to the other side. Subtraction property of equality, same thing, except this time we're subtracting from both sides. So the example at the bottom, 2x plus 4 equals 8. First thing we would do would be to subtract 4 from both sides. That is the subtraction property of equality. Multiplication property of equality, same thing. Whatever you do to one side, you have to do to the other. That's what all the property of equalities are talking about, or properties of equality are talking about. So in this example, if x over 2 equals 3, multiply both sides by 2, so x equals 6. So whatever you multiply to one side, you multiply to the other side. And the last one on the property of equality, that is the division one. So whatever you do to one side, you do the other. So in the example at the bottom, 5x equals 35. Divide both sides by 5. That's the division property of equality. Substitution property of equality. So we talked about substitution when we solve systems of equations. So the substitution property of equality just says that if you know that the value of A is 5, then you can substitute 5 in place of A throughout the problem. So we talked about this thinking in terms of sports, a substitute or a sub in sports. Someone comes out, the other person goes right back in that position. So as long as A equals B, then B can go in place of A at any spot in that expression. So at the bottom, if 2x plus y equals 10, and you know that y is 5, then 2x plus 5 equals 10. So substitution property of equality. Last one, distributive property. So you know distributive property from Math 7-8. So, or actually it might even be Math 6 now that I think about it. But the deal with distributive property, there's technically two types. So the first one listed here is distributive property with addition, and then the second one would be distributive property with subtraction. It doesn't make a difference. It's done completely the same way. So what happens is the number that is outside has to be multiplied to everything inside of the parentheses. So when we have the A outside, that's telling us that that A needs to be multiplied to the B plus C. So we can get AB plus AC. The bottom example, if 3 needs to be multiplied to y minus 2, that's going to become 3y minus 6. So distributive property is beneficial for a lot of reasons. We're going to get into more of that this year. If you look back up at the descriptor ones at the top with the A, B, and C, if you look at the right side, we can write distributive property backwards by saying, hey, both of these two terms were multiplied by A, so I know that A was distributed to the B plus C. So you can go either direction with distributive property, and that's what we're going to work with a little bit more this year. So that covers the algebraic properties that we need to review in this unit. And again, the reason why we're reviewing them is because all of these have some kind of spot in the solution to an equation. So what you're going to be doing is you're going to be looking at different examples of problems that are solved and identifying which property is demonstrated in each step.